ನನಗೆ ಎಷ್ಟೊಂದ್ಸರಿ ನಾನು ಎಷ್ಟು ಸೆಷನ್ ಇದ್ದಾರೆ ಯಾಕೆ ಇಲ್ಲ ಆ ರೆಸ್ಯೂಮ್ ಯಾಕೆ ನೀವು ದೀಪ ಅಷ್ಟೇ ದೀಪ
Is one important compounds of sodium.
Sir,
Yes, ma'am.
so tomorrow do we have NEET exam like that 3 hours one?
Yeah, tomorrow, sir.
It's there, sir.
Yeah, tomorrow compulsory NEET exam, sir.
Thank you, sir.
Important compounds of sodium. Please listen. What are the important compounds of sodium? First one we need to discuss sodium hydroxide. Sodium hydroxide. So in sodium hydroxide, general formula NaOH. This is the first compound. And second compound we need to bear NaOH. Next important compound of sodium is sodium carbonate. Sodium carbonate. The sodium carbonate formula, otherwise it is called washing soda. Washing soda formula Na2SO4, sorry, Na2CO3 dot 10H2. This is the formula for washing soda. Na2CO3 dot 10H2. And third one, we need to discuss about third compound, sodium bicarbonate. Sodium bicarbonate or sodium hydrogen carbonate, NaHCO3. Sodium hydrogen carbonate. We need to discuss this one. Sodium, these three compounds we need to discuss, and fourth one, NaCl. This is called sodium chloride. Sodium chloride, otherwise it is called rock salt. Rock salt, otherwise it is called common salt. Common to discuss about these four compounds. This is the important compounds of sodium. And one more is there, that is called sodium sulfate. Na2SO4, sodium sulfate is called Glauber salt. Glauber salt. Glauber salt formula Na2SO4. These five compounds. Just we need to discuss preparation and uses. That's it. No need to learn chemical properties like that. Preparation part, and we need to discuss uses part. One by one, can I discuss, please? Can I discuss?
Yes, sir.
Yeah. Please note down first one, sodium hydroxide. That's called caustic soda. What is the another name of this compound? Caustic soda. Caustic soda is NaOH. NaOH preparation. So which preparation we need to discuss? Can I erase this page?
Yes,
sodium,
sir.
Caustic soda and sodium carbonate, washing soda, Na2CO3.10H2O, sodium bicarbonate. This is called baking soda. Baking soda. Sodium bicarbonate, otherwise it is called baking soda. Sodium hydrogen carbonate, NaCl, sodium chloride, rock salt, common salt, Na2SO4, sodium sulfate, otherwise it is called Glauber salt. So I'm going to take first one is sodium hydroxide preparation. Sodium hydroxide, NaOH preparation. NaOH preparation, sodium hydroxide preparation. So in this NaOH preparation, first Nelson cell process. Nelson cell process. Nelson cell process. What is a Nelson cell process? In Nelson cell, please note down. In Nelson cell, It's an aqueous solution of sodium chloride. Aqueous solution of sodium chloride, NaCl solution.
Sir, what is this
NaCl.
Nelson cell, sir?
This is the preparation of sodium hydroxide. This is the one
Okay,
process, Nelson cell process. So in Nelson cell, aqueous solution of sodium chloride is the electrolyte. Sodium chloride solution is electrolyzed. That is the electrolyte. Electrolyte or electrolyzed. So here in the Nelson cell, cathode is first electrolyte right now. The electrolyte is NaCl, aqueous NaCl. Cathode is steel acting as a cathode. Anode is carbon is the anode. Please note this point. In Nelson cell, electrolyte is NaCl in aqueous medium. Cathode is steel, anode is carbon. So what will happen? Please listen. NaCl on decomposes, on electrolyzed, will give rise to Na++ Cl minus. In aqueous medium, I told you that's the H2O will give rise to H++ OH minus. Is it clear? NaCl aqueous medium. At least 99% what will be there? Water will be there. Whenever NaCl will dissociated into ions, Na++ Cl minus. And H2O dissolved into water, H2O is dissociated into H++ OH minus. At cathode, what type of reaction will happen? Please listen. At cathode means always what type of reaction takes place? A reduction reaction takes place. Cathode, what is the reaction takes place here? We need to take H plus ion, gaining of some electrons. Gaining of 2 H plus ion, gaining of 2 electrons will becomes hydrogen gas. What gas will liberated at cathode? Hydrogen gas will liberated. So this H plus, that H plus gaining of 2 electrons, it becomes hydrogen gas. At anode, what type of reaction takes place? Please listen. At anode. Anode means what type of reaction takes place? Oxidation reactions takes place. In Nelson cell, what is the reaction? We need to take Cl minus, 2Cl minus. The 2Cl minus gaining of electrons, it becomes, losing of electron. 2Cl minus losing of electron, it becomes Cl2 gas. After losing of 2 electrons, Cl2 gas will form. See, please listen. In Nelson cell process, NaCl is the electrolyte. It will be electrolyzed into Na++ Cl minus. H2O will be electrolyzed into H++ OH minus. So at cathode, reduction reaction takes place. So we make H plus, gaining of 2 electrons, it becomes hydrogen gas. At cathode, hydrogen gas will be liberated in the Nelson cell. And in anode, what type of reaction takes place? Oxidation reaction takes place. 2Cl minus, losing of 2 electrons, it becomes chlorine gas. It becomes chlorine gas. Finally, what is the reaction will happen? If you combine this two, Na plus OH minus together will give rise to NaOH. Na plus OH gives rise to NaOH. This is the preparation of NaOH Nelson cell process. Preparation of NaOH Nelson. What type of questions they can ask in Nelson cell? What is the anode product? What is the cathode product? Anode means what type of product will form? Chlorine gas will liberated. Cathode means what type of gas will liberated? Hydrogen gas will liberated. So this is about sodium hydroxide preparation, Nelson cell process. You need to remember in Nelson cell process, what is the electrolyte? Aqueous NaCl is the electrolyte. Cathode, which one will be there? Steel will be there, cathode. In anode, what will be there? Carbon will be there. What is the cathode reaction? What is the anode reaction? What is the final reaction? Final reaction is in sodium hydroxide preparation. Is it clear?
Clear, sir.
Please note down. Once you're done, you can inform to me. I'll go to next one.
Done, sir.
Hmm?
Sir,
Yes, ma'am.
the screen is not sharing, sir.
Oh shit. Should I write everything again? Hello?
No, sir, that's okay.
No, sir, it's fine.
It's fine, sir.
The next second process that is called Kastner-Kellner process. Please listen. Kastner-Kellner. Kastner-Kellner process. This is also important. Kastner-Kellner cell. This is the second method of preparation of sodium hydroxide, Kastner-Kellner cell. So please note down, first one is Nelson cell, this is Kastner-Kellner cell. Both are preparation of sodium hydroxide. So first I'm going to taking in the Kastner-Kellner cell. In this Kastner-Kellner cell, there are three compartments. First one is called outer compartment. In outer compartment, what type of reaction takes place? Please note down the reactions. In outer compartment, what type of reaction takes place? In outer compartment, cathode is mercury. Cathode is mercury. Anode is graphite. Cathode is mercury, anode is graphite. Electrolyte is aqueous NaCl. NaCl, otherwise it is called rock salt. Otherwise it is called sodium chloride. Otherwise it is called, one more name is there, please note down, this is called brine solution. Brine solution. Brine solution. Brine solution. So here I am going to taking electrolytic solution NaCl. Here electrolyte is NaCl. 2 moles of NaCl on ionization. Ionization or electrolyzer, both are same. On ionization, it gives rise to 2 Na plus Cl minus, 2 Cl minus. It will be dissociate like this in the outer compartment. Is it clear? In outer compartment, cathode is mercury, anode is graphite. Electrolytic solution is aqueous solution, rock salt, sodium chloride, brine solution, all are same. On ionization will becomes Na plus 2 Cl minus will form. At anode, what type of reaction takes place? At anode, means you know very well, I already told you, anode what type of reaction takes place? Oxidation reaction takes place. Cathode always reduction reaction takes place. Oxidation means losing of electron. So losing of electron means when 2Cl minus losing of electron, it becomes Cl2 gas. Losing of 2 electrons. In cathode, what type of reaction takes place? Cathode, please listen. At cathode reduction reaction means gaining of electrons. Once gaining of electron, this Na plus, that Na plus in the cathode, what is there? Mercury is there, combines with mercury, gaining of electron, it becomes Na2Hg. This is called amalgam will form. What is the product will form? Amalgam will form. These reactions will happen in the outer compartment. Is it clear at this point? So in the outer compartment, cathode is mercury, anode is graphite, electrolyte is aqueous solution. Aqueous NaCl is the electrolytic solution. On NaCl ionization, Na plus 2 Cl minus will form. At anode oxidation, 2 Cl minus losing of electron, it becomes chlorine gas. At cathode, reduction reaction takes place. Na plus gaining of 2 electrons, 2 Na plus gaining of 2 electrons. And in cathode, mercury will be there, combines with mercury will give rise to amalgam will form. Clear this point? Yes? Yeah, please
Yes,
note it. Note down.
Done, sir.
It's completed. Hello.
Yeah, sir, done.
Yeah, next one, please note down. In middle compartment, what type of reaction takes place? In middle compartment, what type of reaction takes place? Please note down. In middle compartment, cathode is iron rod. Iron is the cathode. Anode is mercury. And electrolyte is NaCl. Sorry, NaOH. Electrolyte is NaOH. Little bit NaOH we are going to take. NaOH is the electrolyte. At anode, what type of reaction takes place? At anode, oxidation reaction. Oxidation reaction takes place. You know, in the middle, outer compartment at anode, at cathode, this is the product, Na2Hg. That Na2Hg losing of electron, it becomes 2 Na plus mercury after losing of 2 electrons. At cathode, what type of reaction takes place? Cathode, reduction reaction takes place. At cathode, Na plus react with water. This is the electrolyte. This is almost aqueous NaOH. Aqueous means 90% of water. Gaining of 2 electrons gives rise to 2NaOH plus hydrogen gas. 2NaOH plus hydrogen gas. Further, the amalgam react with water. Further, amalgam react with water will give rise to NaOH plus Hg plus hydrogen gas. This is the preparation of sodium hydroxide Castner-Kellner process. First one is Nelson process, second is Castner-Kellner process. Both is very important for sodium hydroxide. Is it clear now? First one also preparation of sodium hydroxide and second one also preparation of sodium hydroxide. First one is from Nelson and second is Castner-Kellner process. Please remember both are very important. Next, sodium carbonate washing soda preparation. Sodium carbonate washing soda preparation. When I start sodium chloride preparation, uses this item, then I go to sodium carbonate preparation. Please follow. It is used for uses of sodium hydroxide. It is used in the manufacturing of
for sodium hydroxide, sir.
gas manufacturing of soap in soap preparation and basis. In the petroleum cycle, in the paper and pulp industry, paper and pulp industry, paper and pulp industry. So which one is is used in the manufacturing of in petroleum cycle, paper and pulp industry. And next compound we will discuss about sodium carbonate. Sodium carbonate is this is called washing soda. Washing soda is called this is sodium carbonate. Sodium carbonate. So this is process we are going to discuss. All of this please remember solving process. Ammonia soda. Ammonia soda. Sodium carbonate preparation soda ammonia process is discussed. Ammonia soda process. This is the modern process used for manufacturing of soda. What are the raw materials? What are the raw materials used for manufacturing of sodium carbonate process? Common salt, and ammonia, ammonia also raw material, ammonia, and limes. What?
Brine solution, sir.
Raw material. Raw material means what are the material going to prepare sodium carbonate in this process. Common salt, ammonia, limestone, so there is a lot of contribution of bonding process. Is it clear? Completed.
Yes, sir.
Okay, next, please note on Sarvey's process reactions. You need to take limestone, you know, there is a limestone formula. CaC3 is the limestone. Limestone will rise to CaO plus CO2. Limestone emitting CaO plus CO2 will form. Again, I told you raw material for preparation of sodium carbonate ammonia. Ammonia react with water molecule plus carbon dioxide will give rise to what is the product will form? Ammonium bicarbonate will form. NH4, NH4, HCO3. Ammonium bicarbonate will. Ammonium bicarbonate. Ammonium bicarbonate will form. Further, that ammonium bicarbonate, NH4CO3. That ammonium bicarbonate reacts with sodium chloride. Will give rise to sodium bicarbonate will form plus NH4Cl. This is the second step. This is the step 1. This is step 2. The step 1, ammonia react with water molecule and carbon dioxide will give rise to ammonium bicarbonate. Further, that ammonium bicarbonate react with NaCl, sodium bicarbonate will form. Sodium bicarbonate will form. That sodium bicarbonate decomposes 2 moles of sodium bicarbonate. This is the step 3. 2 moles of sodium bicarbonate on heat will give rise to Na2CO3 plus H2O plus CO2. This is the byproducts. This is the main products of Solvay's process. This is the formula for calculating Na2CO3. This is called what type of compound? Sodium carbonate. Otherwise, it is called washing soda preparation. That is called Solvay's process. Please go down. First step: ammonia react with water and carbon dioxide will give rise to ammonium bicarbonate. Will give rise to ammonium bicarbonate. That ammonium bicarbonate react with NaCl will form sodium bicarbonate plus NH4 will form. Further, sodium bicarbonate decomposes will give rise to sodium carbonate plus H2O plus carbon dioxide will form. This is the Solvay's process, soda lime process, otherwise it is called Solvay process, otherwise it is called ammonia soda process. That is the preparation of sodium carbonate. Is it clear this one? Clear this soda lime process?
Yes, sir.
Yeah, please complete and then properties I can. Once you done, you can inform to me, please.
So till what time you are taking the class, sir?
8:15 or 8:10.
Okay, sir.
Yes.
Sir, done.
Next, please note down properties of sodium carbonate. Properties. What are the properties of sodium carbonate? The common form is decahydrate. 10H2 is, that's what it's called, decahydrate. Na2CO3 dot 10H2. This is called sodium carbonate decahydrate. This is called washing soda. Washing soda. On heating, Na2CO3 dot 10H2O on heat. On heating will give rise to, please listen, at 375 Kelvin. 375 Kelvin will give rise to Na2CO3 dot H2O will form. Sodium carbonate monohydrate will. Further, it's react with 373 Kelvin. Will give rise to Na2CO3. Will give rise to Na2CO3. Further, that Na2CO3 will form. Na2CO3 further react with water molecule. Will give rise to H2CO3 plus Na plus OH minus will form. Due to the formation of H2CO3 in aqueous medium, Na2CO3 is the basic nature. In aqueous medium, Na2CO3 is basic nature. Due to the formation of carbonate ion. The solution of sodium carbonate is basic due to the hydrolysis of carbonate ion. Hydrolysis of carbonate ion. Is it clear, this one? Na2CO3 10H2O on heating at 375 Kelvin temperature will give rise to Na2CO3 dot H2O monohydrate will form. Further on heating it will form Na2CO3. So Na3, then Na2CO3 react with water will give rise to H2CO3. Carbonic acid will form. Due to the carbonate react with acid, that is called basic in nature. That is indicated basic nature of the compound. What are the uses of sodium carbonate? It is a laboratory agent. I'll write in the next page uses. Please note this point. In aqueous form of Na2CO3 is the basic nature. Due to, what is the reason for that? Due to the hydrolysis of carbonate ion. Once you're done, you can inform to me, please.
Done, sir.
The next one, I'm going to uses of sodium carbonate. Sodium carbonate decahydrate uses. Everyone completed? Yes.
Yes, sir.
Yes, sir.
Sodium carbonate decahydrates. What are the uses? One, it is used. It is as a laboratory agent. Laboratory agent. A mixture of Na2CO3 and K2CO3 is used as fusion mixture. Used as a fusion mixture. Sodium bicarbonate. Next compound, sodium bicarbonate. Baking soda. Baking soda formula NaHCO. Preparation of baking soda. Preparation of baking soda is, so it is a reverse process, intermediate product of Solvay's ammonia soda process. You know, Solvay ammonia process, there is, I think, second process, second step. You know, last Na2CO3 plus CO2 plus H2 will give rise to 2NaHCO3. Last reverse process this is the last step. 2NaHCO3 on heating will give rise to Na2CO3 plus CO2 plus H2. Here the reverse reaction in the Solvay ammonia soda process. Solvay ammonia soda process, the last step, third step, it will be reverse process. You will get sodium bicarbonate. You will get sodium bicarbonate. You will get. This is the preparation of sodium bicarbonate. Na2CO3, sodium carbonate react with carbon dioxide, the presence of water will give rise to sodium bicarbonate. This is called baking soda, sodium hydrogen carbonate. It's a white crystalline solid. It is white crystalline solid. It's white crystalline solid. This is, the solution is alkaline nature. The solution is alkaline nature, basic nature due to hydrolysis. Due to hydrolysis, this is also basic nature due to hydrolysis. So whenever NaHCO3 on react with water will use rise to NaOH. Due to the formation of NaOH, H2CO3, this is called basic nature example. Basic nature example. I hope this is the physical properties of the sodium bicarbonate. What are the uses of sodium bicarbonate? Please note down, next one is the uses of sodium bicarbonate. Baking soda. Is it clear?
Yes, sir.
Yeah. Please note down, baking powder, where will be there? Baking powder is more commonly used. It contains baking powder. Baking powder is more commonly used and contains NaHCO3 and CaH2PO4 taken and starch. More commonly used in this, contains these compounds. Next compound, sodium chloride, NaCl. NaCl is called rock, otherwise it is called brine solution. brine solution. This is the common salt. Common salt. Table salt. Otherwise, it is called, what is that? Table salt. We can ask what is the formula of table salt, brine solution, rock salt, sea salt. They can ask that one. So, what is the manufacturing of NaCl? Manufacturing of NaCl. So, generally, it is obtained from the seawater. Seawater. 2.7 percentage to 2.9 percentage of NaCl is allowed to dry up under summer heat in the small tanks. Is allowed to dry up under summer heat in small tank or pits. The solid crust so formed is collected. So generally where we are going to preparing this common salt means in the seawater. Generally in the seawater 2.7% into 2.9% of NaCl is allowed to dry up under summer heat in the small tanks and pits. The solid crust so forms is collected. Is it clear? NaCl is neither deliquescent nor hygroscopic. Hygroscopic nature. Please note this is most important. NaCl is neither deliquescent nor hygroscopic, but it is moistured due to the presence of impurities like CaCl2 and MgCl. Moistened. So please note down NaCl is neither deliquescent nor hygroscopic, but it is moistened due to the presence of impurities like calcium chloride and magnesium chloride. Calcium chloride and magnesium chloride. Those points you need to remember. NaCl is not deliquescent or nor hygroscopic, neither deliquescent nor hygroscopic, but it is moistened due to the presence of impurities like magnesium chloride and calcium chloride. This is about sodium chloride, common salt. This is the important component. Understand important compounds of sodium. First one, sodium hydroxide, Nelson cell process. Another process is Caspar-Campbell process. And second compound, I told you, sodium carbonate preparation. That's called Salve process. Soda ammonium process. That is also most important. You need to remember uses of sodium carbonate. After that, sodium bicarbonate, baking soda preparation, and uses you need to remember. Finally, sodium chloride preparation. Sodium chloride, that is called rock salt, brine solution, common salt preparation. You need to remember. And next one, sodium sulfate decahydrate, Glauber salt. Please listen. What is Glauber salt formula? Sodium sulfate, Na2SO4 dot NH2.
Sir, 1 minute. Can you go to previous page, sir? 1 minute. Okay, sir.
Yeah. Next, sodium sulfate. Sodium sulfate formula, otherwise it is called Glauber salt, decahydrate. Decahydrate. Decahydrate formula Na2SO4 dot NH2. Glauber salt. Glauber salt. So that Glauber salt, how to prepare that Glauber salt? Yeah, please note on one more point. Anhydrous. Anhydrous means without water molecule. Anhydrous sodium sulfate. Anhydrous sodium sulfate Na2SO4 is also called salt cake. Salt cake this is. It is a byproduct of HCl industry. Byproduct of HCl industry. So how to prepare its Na2SO4? NaCl react with H2SO4 will give rise to Na2SO4 plus 2HCl. So this is the byproduct. So this is the preparation of sodium sulfate. Sodium sulfate decahydrate is called, what is that? Glauber. Please know this point. Na2SO4 is used in paper industry, detergent, glass manufacturing. Glass manufacturing. So this is about Leiber salt preparation uses. Is it clear? This is the important compounds of sodium. Any doubts is there you can ask, otherwise we go to hydrogen based compounds. Once you done, you can inform to me, please.
Done, sir.
Is it clear now? Important compounds of sodium or not? Yes, next. Hydrogen and its compounds, please listen. Hydrogen and its compound. Hydrogen and its compounds. You know very well in this chapter, in the period table, where is the hydrogen atom? Can you tell me where is the hydrogen? So hydrogen has similarity with alkali metals and it has resembled with halogens. That's why the position of hydrogen, they are not decided. It's the lightest gaseous element. Hydrogen is lightest gaseous element. Lightest gaseous element. It has one electron. It has one electron, one proton. There is no neutron. No neutron. Is it correct? See, 1H1. One electron, one proton, one zero neutron. There is no neutron. So what are the hydrogen isotopes? 1H, this is the hydrogen isotope, protium. Protium. So we can't tell position of hydrogen atom in the periodic table because it has similarity with alkali metals. What is the similarity with alkali metals? Resemblance with alkali metal. What are the resemblance with alkali metal? Please listen. It has only one electron in the outermost shell. Only one electron in outermost cell. Is it correct? Even alkali metal has one electron in the outermost shell. Even alkali metal has one electron in the outermost shell. Even alkali metal has one electron in the outermost cell. Next, after that, next one. So hydrogen will form unipositive ion. Even alkali metal will form unipositive ion. Unipositive ion. Even alkali metals will form unipositive ion. Exhibit only one oxidation, +1 oxidation state. Exhibit +1 oxidation state. Please complete that one. It has only one electron in the outer motion. Even alkali metal has one electron in the outer motion. Unipositive ion, even alkali metal shows unipositive ion. And it exhibits +1 oxidation state. Is it correct? Next point. Nothing is big. Nothing is big.
Done, sir.
Yeah, next, please note down. Next, exhibit +1 oxidation state. Exhibits +1 oxidation state. Even alkali metal exhibits +1 oxidation state. Forms oxide. Forms oxides, halide, and sulfide. Forms halide, oxide, sulfide. Act as reducing agent. Act as reducing agent. Act as reducing agent. This is the resemblance with the alkali metals. So even hydrogen form oxides, hydrogen form halides, hydrogen form sulfides. Hydrogen form sulfides. So resemblance with the halogen atom. Please listen that one. Resemblance with halogen. Please listen this one. What are the similarity with halogen atom? Hydrogen is non-metal. Even halogens are non-metal. Hydrogen is non-metal. Even halogens are non-metal. Form uni-negative ion. Correct? Form uni-negative ion. Minus will form like that. Cl minus, F minus, Br minus, I minus will form. Exist diatomic molecule. Exist diatomic molecule. Even halogens will exhibit diatomic molecule. Chlorine, bromine, iodine, like that. Even hydrogen will exhibit diatomic molecule. Exhibit -1 oxidation state. Exhibit -1 oxidation state. Even halogens will exhibit -1 oxidation state. Where hydrogen atom will exhibit -1 oxidation state? In hydrate form, hydrogen -1 oxidation state. Hydrate, calcium hydrate, sodium hydrate, barium hydrate, like that will form. Is it clear? That's why the position of hydrogen atoms still they are not decided whether it is a first A group element or 17th. It has similarity with first A group element. It has similarity with 17th group element. Is it clear?
Yes, sir. Sir? So will
Yes,
there be
ma'am.
given a problems based on this chapter or only theory part?
Theory part, no problem in this chapter.
Okay, sir. Thank you.
Next one. After that, please note down next one. Ionization potential. Ionization potential. Ionization potential 13.5 electron is nearer to value of fluorine. Is nearer to the value of fluorine. Is fluorine. Hydrogen react with non-metal. Hydrogen react with non-metal. Non-metal form covalent compound. To form covalent bond. Example CH4, SiH4, GH4, and even alkali. Sorry, halogen atoms are metals. Its covalent bond is there. Covalent bond is there, and some difference from alkali metal. Difference from alkali metal. What are the difference from alkali metal? Difference from alkali metal means I can say ionization energy of hydrogen is very high in the comparison to alkali metal. Ionization of hydrogen is very high in comparison to alkali metal. Comparison to alkali metal. Unlike alkali metals, these are metals. Hydrogen is non-metal. Hydrogen is non-metal. Hydrogen is diatomic molecule, whereas alkali metals are non-monatomic molecule. Hydrogen is diatomic. Hydrogen is diatomic molecule. Alkali metal is monatomic. Is it clear?
Yes, sir.
Yeah, please complete first. That's fine. Please listen. NaCl is ionic nature, while HCl is covalent nature. Understood? HCl is covalent nature. Like H2O is amphoteric oxide, while alkali metal oxides are basic nature. Alkali metal oxides are basic nature. This is the difference from hydrogen atom in the alkali metals. What are the difference in halogen atom? Difference from halogen. Hydrogen has one electron in its valency cell. Valency cell, while halogen has 7 electrons. So this is the difference between halogen. What are the isotope of hydrogen? 1H1, 1H2, 1H3. This is called protium, deuterium, and tritium. 1H1, 1D2, 1D3, tritium. Tritium is the radioactive element. Remaining all are what type of elements? Radioactive, normal elements. Tritium half-life is 12.33 years. 12.33 years. Tritium half-life. Protium, deuterium, tritium. This is the isotopes of hydrogen. 1H1, 1D2, 1H3, or 1H2. Is it clear or not? Is clear or not?
Yes, sir. Clear.
Next. Hydrates. Hydrates. What are the types of hydrates are there? Please note down. I'll start now hydrates topic. Hydrate. Actually, hydrate, there are 3 types of hydrates are there. Ionic hydrate, covalent hydrate, metallic hydrate. There are 3 types of hydrates are there.
Excuse me, sir.
Yes, tell me now.
Sir, in exam, it's asked tomorrow Clark's method, Calvin's method, and what to do, sir. The of sodium peroxide.
Preparation of sodium boroxide.
Peroxide.
They won't
Sodium
ask.
peroxide.
They won't ask that one, Anand. Don't worry. They won't ask.
Okay, sir, fine.
Only they will ask sodium carbonate, sodium bicarbonate, NaCl, like that only they will ask.
Okay, sir. And this
What are
uses of dihydrogen
yeah,
laboratory
dihydrogen?
preparation.
The preparation part is not there, I guess. Check once if you want.
Okay.
Hydrates. There are 3 types of hydrates are there: ionic hydrate, and covalent hydrate, and metallic hydrate. Generally, first A group element and second A group elements combined with hydrogen will form ionic hydrate. And rest of the group element 13, 14, 15, 16, 17, 18 group element react with hydrogen will form covalent hydrate. Metallic hydrates means D block elements will give rise to metallic hydrate. Understood? What is the ionic first? Ionic hydrate. Ionic hydrate, please note this point. Here, these are the stoichiometric compound, generally S block element. S block elements react with hydrogen. React with the hydrogen will form will form ionic hydride. S block elements means first A group element and second A group element. First A group element and second A group. S block elements react with hydrogen will form ionic hydride. S block element means first and secondary group elements. Secondary group elements react with hydrogen will form ionic hydrides. Generally, lithium hydride, sodium hydride, beryllium hydride, and magnesium hydride. These all are covalent hydrides. These all are what type of hydrides? These all are covalent hydrides. Covalent hydrides, which in water, which is insoluble in water. Insoluble in water. I know yesterday only I told you BH2 and MgH2 are polymeric structure, polymeric hydrides. Polymeric hydride. CH2 is called hydrolith, like that I told you. Hydrolith. Is it clear this points? Yesterday I told you this 3 points in all. Did you understand this point? Hello? Can I go to next one? Hello? Hello? Completed? Please respond. Completed or not?
Yeah, certain.
Next, covalent hydride. Please note down. There are 3 types of covalent hydrides. What are the 3 types of hydride? One is called electron precise hydrate, electron precise hydrate. Another one is called electron deficient hydrate, electron deficient hydrate, and electron rich hydrates, electron rich hydrate. What are the electron deficient hydrates? Electron deficient hydrates means 13th group element. 13th group element react with hydrogen will give rise to electron deficient hydrates. Like what type of hydrates will form? BH3 type of hydrate, ALH3 type of hydrate, and B2H6 type of hydrate, and GH3 type of hydrate. These all are electron deficient molecules. Because of boron around there are 3 hydrogen atoms are there. Only 6 electrons, not satisfied by octet configuration. Hence that's called electron deficient hydrates. What is the meaning of electron precise hydrate? 14th group element react with hydrogen will give rise to electron precise hydrate. What are the examples for electron precise hydrate? Methane, SiH4. Exactly 8 electrons are there in the around the central metal atom. That's why it's called electron precise hydrate. What is the electron rich hydrate? Electron rich hydrate means 15th group element, 16th group element, 17th group element react with hydrogen will form electron rich. Excess of electrons will be there. NH3, nitrogen having lone pair of electron. Water, oxygen having 2 lone pair of electron. Nitrogen having 1 lone pair of electron. HF, fluorine having 3 lone pair of electrons. So that's why this is called electron rich hydrates. Electron rich hydrates means it has excess of electrons. Excess of electrons. So 13th group element combines with hydrogen will form electron deficient hydrates. Electron deficient, otherwise it is called Lewis acids. No, yesterday only I told you why it is called Lewis acids, because of less than 8 electrons are there in the outermost shell. That's why it's called electron deficient molecules. So this is for electron precise. Around the central metal atom, there are 8 electrons are there. That's why it is called electron precise. Exactly 8 electrons are there. That's why it's called electron precise. Electron precise. So electron rich H2O, HF, electron rich hydrates because of nitrogen having 1 lone pair of electron, oxygen having 2 lone pair of electron, fluorine having 3 lone pair of electrons. This is called Lewis acids, electron deficient molecules. This is called electrophiles. This is called Lewis bases, nucleophiles. This is nucleophile. Lewis base, nucleophile, electron rich hydrates. After that, I can say interstitial hydrates. Last one metallic hydrate, otherwise it is called interstitial hydrates. What is the meaning of interstitial hydrates? D block elements combines with hydrogen atom will form metallic hydrates, otherwise it is called interstitial hydrates. Even D block element and lanthanides will give rise to what type of hydrates will form? Interstitial hydrates will form, otherwise it is called metallic hydrates will form. Is this clear, these points or not? Please tell me. Any doubts is there? My Tuesday, one more class, I will complete this chapter. Can I leave the meeting? Hello? Hello?
Yes, sir.
Yeah. Tuesday, one class I will take. That time hydrogen, water, and soft water. What is soft water? What is hard water? That 2 topics I will cover in the Tuesday. Is it fine?
Yes, sir.
Yeah. Thank you, ma'am.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, ma'am. Tuesday I will cover water and then soft water, hard water. What are the removal of hard water that we will discuss. I'm going to end the meeting.